Hello, my name is Justice, and this episode is brought to you by light. Light is very, very interesting, and a long time ago it used to be just seen as a particle, but science tells us now that that's not truly the case. Allow me to explain why light keeps me up at night. Have you ever heard of the double slit experiment? The double slit experiment is very interesting. But before I tell you about that, allow me to explain a particle and a wave. A particle, mass, which like I said, light used to be said to be just mass. If you have a single slit in a wall, just a single slit, and light is shining through it to the back wall, you're going to get a bunch of dots that resemble a line. And now, if light was just a particle, and there were two slits in the wall, what you would end up with is a bunch of particles that have to go through either one slit or the other slit. And in doing so, on the back wall, you would get particles lined up to reflect that. Particles over here, imagine these lines are billions of little dots, and this is what you would see on the back wall. Now a wave is very different when it comes to this predicament. A wave shined through a single slit in the wall. On the back of the wall, what do you think you would see? What do you think you would see on the back of that wall? You would see something just like you would see from a particle. One slit, one destination point. Common sense. Sounds good to me. But there's an interesting thing about a wave. If you have two slits diagonally on a wall where a wave can pass through, on the back wall, what do you think you're going to see? Take a second and guess. Imagine if you would, and I will explain why it is the way that it is. On the back wall, you will see something along these lines. Now, please keep in mind that the black lines on this paper represent the impact points on the back wall when it comes to waves. The spaces in between, if the maximum point of one wave and the bottom point of another wave meet, they cancel themselves out completely. And in doing so, you get empty spaces. So you have one brightest point, or like strongest point in a wave connecting on the back wall, and then you have fractals that get weaker and weaker off of the main point, where it spreads out and they hit and hit and hit and hit as the waves collide into each other and onto the back surface. So scientists theorized, alright, so if we shoot light through two slits in a wall, tell me something. What do you think they would see? Remember, up until this point, light was considered a particle. They thought they would see two lines. What did they actually see? This again. Scientists were baffled. What? How is this possible? Particles acting like a wave? This can't make sense. So they got together and they thought about it, and they were like, what must be happening is the particles are colliding in with each other, producing similar outcomes as a wave would colliding into each other. Like, alright, how can we prevent this from happening? I know. Let's take a particle and shoot one particle at a time through two slits. Well, let me tell you what happened. They photographed the impact points of every individual particle on the back wall. And within a few hours, boom, they ended up with this. Again. Granted, not all at once. Like, they would shoot a particle through, and not only is this weird, the fact that it did this with one particle, But it also meant that when the particle came to the slits in the wall, 4 things happened simultaneously, which is impossible for all 4 of these things to happen simultaneously. 1, the particle split into 2, went through both holes, came back together. The particle didn't go through either one of the slits. The particle went through one slit, and the particle went through just the other slit. All 4 outcomes had to have occurred with each particle in order for this to be the outcome. How scientists were baffled. What? How can light do this? Light's a particle. Yet it's acting like a wave. And even when we shoot one particle at a time through 2 slits, black magic happens and we get this still. So scientists was like, alright, we're smart. I know what we'll do. We're going to figure out where that particle goes. So they set up an object that could watch the particle as it picked which slit to go through. And let me ask you this. What do you think was on the back wall when they were watching the particle? Well, shooting one particle at a time for hours, pew, 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 they ended up getting 2 lines like you would from a particle and not like a wave. So scientists were like, what? So it acts like a particle when it's being observed, but it acts like a wave when it's not. How is this a thing? What part of the equation equals it acting like a particle or acting like a wave? So the simple fact of observing a particle somehow enters into the equation of what a particle becomes, or what light becomes, I should say. Does light become a particle? Does light behave like a wave? And why is it that pure observation changes the outcome? Do you realize how mind-blowing this is? Just by observing something, you've completely changed the structure of light itself. Like, if that doesn't blow your mind, I don't know what will. But the question is, why does it happen? We don't know. Does it happen? Yes. Now, I have a theory as to why this happened. And in order to get that theory, you have to watch later episodes, because this is going to build up into one ultimate outcome. So, this is where it gets even weirder. If you're not weirded out or like obsessed by now, you're about to be. So, this experiment is still being tested to this day. Scientists was like, okay, I know what we can do. We will send a light particle through 2 slits like normal without being observed, right? We're not going to observe when it goes through the slits, because doing so clearly changes the outcome. What we're going to do is set up a machine that has a random algorithm, 100% random, not chosen by human, that will choose 1/billionth of a second before the particle hits the back wall to whether or not it's going to observe the back wall to see where the particle hits. Because by the time it's that close to the back wall, it's impossible for it to alter being a wave or a particle. So we will be able to actually see what it is truly before it hits the wall. So scientists got together, programmed this machine, set it to work. This is when something weird happened. It's as if light itself could travel back in time. What do I mean by that? The machine would choose one fraction of a fraction of a fraction of a second whether or not it was going to look. And just by the act of looking or not looking, scientists say this, that the particle, the only way this works is if the particle actually goes back in time to before it was fired, knowing what the outcome would be, and then came through and went through, because by the time we observed, it already went through the 2 slits. So the only way it could change itself was whether or not it went back in time to change itself to whether or not we were viewing it. Because no matter how close of a fraction of a second it was before hitting the wall, if we viewed it, it would be a wave. If we didn't view it, it would line up in parallel lines like a particle. I don't think you understand. So when we were viewing it, it had already chosen whether or not we were going to view it. Like, it either knew whether or not the machine was going to view it, or it traveled back in time to before it was fired out, already after knowing whether or not it was going to be viewed, so that it could go through the two lines in order to be the proper outcome. How does that work? We don't know. But we know it's got to be, it is affected by whether or not it's being viewed. 100%. Light is being affected by us just simply looking at it. And we also know that even if we try to break the rules by looking at it after it's chosen what to do, it will go back in time and make the alternate choice. There's no way around it. If that doesn't keep you up at night wondering, I don't know what will. Thank you for viewing episode 1 of Things That Keep Me Up at Night. This is a new series I'm starting on YouTube. Please like, favorite, and share on your favorite social medias. I look forward to seeing you on the next episode.